Hi guys, today I'll be explaining the chemistry quiz of term 1 week 3. Before we start with the quiz, I just want to write a general amount of rules that apply to this quiz and the exam. So first thing is that we have delta H, we have endo and we have exo. For endothermic, the products have more heat than the reactants. So if we're gonna draw the graph of an endothermic reaction, we're gonna have it like this. We're gonna have the products, we're gonna have it like this. We're gonna have the reactants down, they have less heat, and the products on top, they have more heat. Now, if we have an exothermic reaction, the reactants have more heat than the product. So if we're also gonna draw the graph, we're gonna draw it like this. The reactants have more heat than the products. So this is the first general rule. The second general rule is about the enthalpy change. There are, I believe, 3 cases, and the first case is bond energy. These are all examples of enthalpy change. Enthalpy change isn't just one thing, it's a general label for these 3 types of heat change. So first is bond energy. Whenever you see bond energy, or they give you a bunch of bonds, what do? You do the heat, the sum of heat of reactants minus the sum of heat of products. This equation is very important because bond energy is the only equation in chemistry that does reactants minus products. Usually it's products minus reactants. Now, the second one of enthalpy change is the formation, is the enthalpy change of formation, or delta H of formation in other terms. Okay, the formation, whenever you see formation, combustion, anything that has of, so delta H, it will show in the exam delta H, for example, combustion. Anytime this appears in the exam, the equation is the sum of heat of products minus the sum of heat of reactants. Okay, this is for formation, combustion, like the delta H of something. Okay, now the final enthalpy change is the general delta H. So whenever you see delta H by itself, okay, you have to read the question and you have to deduce whether it is endothermic or exothermic. If it is exothermic, then the equation will be negative Q over N. But if it is endothermic, then the equation is going to be Q over N. Now, what is Q and what is N? We will deduce later in the quiz if we have a question that will use this equation. Now, finally, we have the calorimetry. And so there's an equation that is related to calorimetry. It is Q equals M times C times delta T. Q is the final energy, M is the mass, C is the temperature needed to raise 1 degrees Celsius of 1 gram, okay, and delta T is temperature final minus temperature initial. So this is all for just a quick recap about what this quiz will have and like a general summary. So now we can start explaining the quiz. Which of the following symbols refers to the heat content of a substance? They didn't say the change of heat content, so there's no need for delta H because there's no change. So the heat content is then H. Always pay attention, read the full question, it will really help out. Question number 2. Which of the following is an endothermic process? Endothermic will take in heat, so the products will have more heat than the reactants. Meaning, if you heat carbon with water vapor to form hydrogen gas, definitely if you're heating something, okay, it will take in the heat, so the products will have more heat, so it is endothermic. Cooling water vapor, you're cooling water vapor, which is a gas, it will become a liquid, so it's not endothermic, it's exothermic. Reacting NaOH with HCl, they didn't give us enough information. We don't know what happens when NaOH reacts with HCl, so definitely not. And finally, melting an ice cube. And when you melt an ice cube, it will become a liquid, and the liquid, it has more heat, it moves like more than an ice cube, so it is an endothermic process. Question number 3. Which of the following is the energy diagram for an endothermic reaction? When we talk about endothermic, we mean that the products have more heat than reactants. So you're gonna draw the graph like this. Okay, this is our reactants and this is our products. It's supposed to be something like that. So it's always an upward curve, never a downwards curve. So that means our correct answer is this. Question number 4. Consider the following reactions. Which of the following expressions gives the heat of formation of CO2? Now this is something derived from Hess's law. We will reach Hess's law somewhere in the quiz, but for now, look how we solve this. Up here are all the reactants, and in the bottom is our final product. Now, if you notice at the beginning, we have in the reactant side C. So we have to look for the equation, one of these 3 equations that contains C in them. And it has to be in the reactants. So C is in the reactants, okay? And this is the only equation that has C, and it is in the reactants. So we keep it for now. Actually, no, we don't keep it, because look at the difference in coefficients. We have 2 over here, and over here we have 1. So how does the 2 become a 1? We divide the whole equation by 2. So all of this, we divide it by 2 or multiply it by 1 over 2. Now we finished with the C. We are safe with the C. For the O2, okay, if you see O2 in more than one equation, we always leave it for the very last, the very final thing. Now the CO2, it is a product and its coefficient is 1. So which equation has CO2? This is the only equation that has CO2, but its coefficient isn't 1, it is 2. So that means we also have to multiply this by 1 over 2. Now finally, let us kind of write these equations. This will become C solid plus 1 over 2H2 gives us C2H2. And the second equation is 1 over 2 C2H2. Oh, over here I forgot the 1 over 2. So this equation over here is 1 over 2 C2H2, okay, plus 5 over 2 times 1 over 2 is 5 over 4 O2, okay. It will give us, I can't fit it here, so I'm just gonna put it like this. It will give us what? CO2 plus 1 over 2 H2O. If you notice that we do not have C2H2 in this equation, and we do not have H2 in this equation, and we do not have H2O in this equation. So what we need to do is we need to get rid of these three compounds. We need to find a way to get rid of them. To do that, you need to have the same compound, the same coefficient, okay? But they have to be in opposite sides, so then you can subtract. So let me just rewrite everything properly. We have C plus 1 over 2H2 gives us 1 over 2 C2H2. And then we have 1 over 2 C2H2 plus 5 over 4 O2 gives us CO2 plus 1 over 2 H2O. So in these two equations, the only thing that we can cancel out of them is the C2H2. That means to get rid of the 1 over 2 H2O and to get rid of the 1 over 2 H2, we need to take this equation and we need to flip it. Because if you noticed, we have H2 in the reactants, but we need it to be in the products. Actually, no, Amanda. No. Amanda, re-explain this and cut all of that part out. So question number 4. This is something derived from Hess's law, which we will reach it later. Here is a really deep way on how to do it, so please pay attention. In the final product of these three reactions, okay, we have C solid plus O2 gas gives us CO2 gas. So the only three elements and compounds we need are C, O2, and CO2. Okay? Meaning, let's start. First of all, C solid. In which equations can you find C solid? You can only find it in the first equation. Now, here, C solid is a reactant, and over here it is a reactant, so we don't need to change anything. We keep it just as it is. But if you notice, the coefficient is 2 C solid, and here it is 1. So to change the 2 into a 1, we divide or we multiply the full equation by 1 over 2. Now we are finished with the C solid. Next, we have the O2. Which equations have O2? We have this equation and this equation. We will leave it for last because if we have any compound or element in more than one equation, then we always leave it for last because it will balance out itself. It will balance itself out. Now CO2. Which equation has CO2? This equation has CO2. And here it is a product, here it is a product. Here the coefficient is 2, here the coefficient is 1. So that means we multiply this by 1 over 2 as well. Now before we continue, let us write the proper form of these equations now that we solved them. We have C solid plus 1 over 2 H2 gives us 1 over 2 C2H2. The other equation is 1 over 2 C2H2 plus 5 over 2 times 1 over 2 is 5 over 4 O2 gives us CO2 plus 1 over 2 H2O. Now, if you noticed, we have 3 compounds that are not needed in this. We do not find them in this final equation. So what are they? They are the C2H2, the H2 and the H2O. So we need to get rid of them. To do that, we need to have the same compound with the same coefficient in opposite places. Meaning, for example, the 1/2C2H2. Here it is in the product, and here it's the same compound, the same coefficient, but in the reactants. So we can directly subtract them. 1/2 minus 1/2 is 0, okay? So they cancel out basically, and we already removed the C2H2. Now we need to remove the H2 and H2O. But if you noticed, here we have 1/2H2 in the reactants, and this equation, which we did not use yet, but we will use now, we have H2 in the reactants. So how do you make 1/2H2? How do you make, H2 into 1/2H2 and in the products? Whenever you multiply an equation by a negative number, it flips. So now it's gonna be H2O gives us H2 plus 1/2O2. But we need 1/2H2 to get rid of the H2, so we multiply it by negative 1/2. Now this equation will become what? It will become 1/2H2O, okay, gives us 1/2H2 plus 1/4O2. Now we have here 1/2H2O and 1/2H2O. One is in the products, one is in the reactants, so we can cancel them out. They're not actually canceling, it's more of subtraction, because if you do 1/2 minus 1/2, you will get 0. Same here, 1/2H2 and 1/2H2 over here, so we can cross them out because they eliminate each other. This leaves us with what? With 5/4O2 in the products and 1/4O2 in the reactants. So let us subtract them. 5/4O2 minus 1/4O2, it gives us 4/4O2, which is basically 1O2. So from all of this, which equation did we get? We got this equation, because if you look, we have 1C over here, we have 1CO2 over here, and we got the 1O2 over here. And don't forget about the energy. We multiplied the energy. Here we multiplied this by 1/2. We multiplied this by 1/2, and we multiplied this by negative 1/2. Don't forget, negative 1/2. So it will be basically 228 times 1/2 plus minus 1300 times 1/2 plus minus 286 times minus 1/2. If you take out the common, which is 1/2, you will now have 1/2 times 228 minus 1300, but here the minus will come here, and minus times minus is plus, so plus 286. So we got this heat, and it is 1/2, here it is this one, and the heat of formation will be then on your calculators 1/2 times 228 minus 1300 plus 286. It will be then negative 393 kilojoules. Question number 5. Which of the following represents the equation expressing the heat of reaction per mole of N2? Here we have half a mole of N2. So how do we make half a mole become 1 mole? We multiply it by 2. So just multiply the full equation by 2. We're going to have N2 plus 3H2 gives us 2NH3. Now, negative 46 kilojoules per mole. Negative means it is what? Exothermic. exothermic means there is heat in the products. So we also need to multiply this by 2. We are gonna get 92 minus 92 kilojoules per mole. But instead of minus 92 in the reactants, we are gonna do plus 92 kilojoules in the product. So our equation was N2 plus 3H2 gives us 2NH3 plus 92 kilojoules. And they told us what is the change in energy when 2 moles of NH3 are produced. 2 moles are produced above. So what we basically have to do is put how we got the plus 92. In fact, it's minus 92 because it is in which side? Always, if it is in the product side, then the energy is minus 92, for example. But if it is in the reactant side, then it is plus 92. Because here, in the reactants, you gain heat, and here you lose the heat. So it is negative 92 kilojoules. Question number 6. The energy needed to separate 2 hydrogen nuclei apart. How are hydrogen nuclei together? They have bonds. So the energy needed is called bond energy. Question number 7. The change in heat content, the change is always delta and heat content is H, so it is delta H. Question number 8. Here's Hess's law. Hess's law states that the heat evolved or absorbed by a reaction is independent of the path followed. We don't care about the path, okay? But instead it depends on the initial reactants and the final product. So it's independent of the path followed, and it depends on the initial reactants and the final products. Question number 9. This came in last week's AMS quiz. A group of students are asked to measure the amount of heat generated during a reaction. They need an experimental procedure. So they use a calorimeter or a bomb calorimeter inside, they use the bomb calorimeter, but they measure the change in temperature, but the volume has to remain the same. So they measure the change in temperature inside a bomb calorimeter in which the volume of the system remains constant. Question number 10. Calculate the enthalpy change. Okay, this is one of the enthalpy changes between this and the bond energy values. We said bond energy is reactants minus products. It's the only equation that uses reactants minus products. So to calculate the bond energy here, this is our reactants. What do we have? We have 1 times C-double-C bond plus 4 times CH bond plus 1 times Cl-Cl bond. And if you follow the bond energy table, you're gonna have 1 times 602 plus 4 times 413 plus 1 times 240. We will get here 2494. Now here in the products we have 1 times CC bond, okay, plus 4 times CH bond plus 2 times CCl bond. So if you follow what we did and you try it on the calculator, we're gonna have 1 times 336 plus 4 times 413 plus 2 times 327. We will get here 2652. And the equation was reactants minus products, so we do 2494 minus 2652. We will get negative 150. 58 as our answer. Nitrogen dioxide NO2 is one of the gases that causes acid rain. Okay. This is again one of Hess's laws. Okay. The point of Hess's law. We have this as the final equation, and we have these two these two initial equations. Now we will check. First of all, we have NO gas in the reactants and its coefficient is 1. Check which equation has NO gas. This one. It is in the reactants and its coefficient is 1. So we keep it as it is. Then, second of all, we have 1/2 O2. Do we have O2 in more than one place? Yes, so we will keep it for last, okay? Finally, we have NO2 as a gas, okay? And its coefficient is 1. Here also, we have it as a gas. It is in the reactant side and its coefficient is 1. So for the NO and the NO2, we are safe. Now, let us go to the 1/2 O2. We have O2 over here and we have O2 over here. As we need what? We need O2 in the reactant. So you can multiply either this by minus or this by minus. But if you multiply this one by minus, then you're also going to change the position of the NO gas and the NO2 gas, which we need to keep the same because they are correct. So then we will keep it as it is. Another thing, we have an extra compound, which is the O3 gas. So to get rid of it, here it is in the products and here it's also in the products, we can multiply the equation above by negative to switch it. So now it is 3O2 gives us 2O3, but here the coefficient is 1, and to get rid of it, we need to make this coefficient 1, so we not only multiply it by negative by negative 1/2. So our equation now is 3/2 O2 gives us O3. Okay, now we can cancel. You can cancel the O3 with the O3, and now you are left with 3/2 O2, and you only have to subtract it from the O2 gas. 3/2 O2 minus 1 O2 gas. The 1 from math, it will become what? 2/2. So now we have 3/2 O2 minus 2/2 O2, which will give us 1/2 O2. And we did it how? Only by multiplying this equation by negative 1/2. So the heat of this reaction, which we will call delta H3, is gonna be minus 427 times minus 1/2 minus 122. So it is gonna be, it's actually plus minus 122. So minus 427 times minus 1/2, okay, plus minus 122, we are gonna get 91.5, and don't forget the plus. So our answer is positive 91.5. Question number 12. Calorimetry is the measurement of reaction heat. Okay, this, remember it came the opposite in the exam. It came, the measurement of reaction heat is calorimetry. So please memorize it. Question number 13. To change the temperature of a particular calorimeter, oh look, first of all, we have delta H, yes? And they didn't tell us, they didn't give us any bond energy, okay? So that means delta H is either Q/N if it is, Q/N if it is endothermic, and minus Q/N if it is exothermic. The keywords to know if it's endothermic or exothermic is combustion is exothermic, and if there's a temperature rise, then it is exothermic. Meaning, we use this equation minus Q over N. Q, it's not the same Q as Q equals M times C times delta T. The Q of a liquid or a gas in this case, because we have ethene gas, okay, it is the energy needed to raise it's the energy needed to raise by 1 degrees of 1 gram, okay, multiplied by the delta T over the number of moles, which is mass over molar mass. So now, if we're gonna take this equation, remember the C is the energy needed to raise 1 gram by 1 degrees. The delta T is temperature final minus temperature initial, and N is mass over molar mass. So our C is what? It is 5 kilojoules, okay? Our change in temperature, it rose by 5 degrees, so it is 5. We put it over the mass, over the molar mass, the number of moles. So 5 times 5 over 7 over 28. But don't forget the minus. So it is gonna be minus 5 times 5 over 7 divided by 28. We are gonna get negative 100 kilojoules per mole. Question number 14. Calculate the heat of the reaction for this. Okay, it's another one of Hess's law thingy. Okay. First of all, we have CO as a gas. We need it to be in the reactants and its coefficient is 1. This equation has CO, but it's not in the reactants, it is in the product. So to make it in the reactants, we multiply it by negative 1. So now the equation is CO gives us C plus 1 over 2O2. Then we have CO2 as a product and its coefficient is 1. Here we have CO2 as a product and its coefficient is 1. We left O2 for last because we have it in 2 places, okay? So now we can do C plus O2 gives us CO2. The C will cancel with the C. The O2, you subtract it from the 1 over 2 O2, so 1 minus 1 over 2, which is 2 over 2 minus 1 over 2, which gives us 1 over 2 O2. So we did all of this only by multiplying this by negative 1. So to find the delta H3 of this one, it is minus 1 times minus 110 plus minus 393. So it will be minus 1 times minus 110 plus 300 plus. It is going to be negative 283. So our answer is minus 283. Question number 15. They need us to rewrite the equation expressing the coefficients as the smallest whole numbers. So if this is 1 over 2O2, to make it 1, we multiply it by 2. So now our equation is 2C solid plus 1 over 2 O2 gas, okay? Sorry, not 1 over 2, plus O2 gas gives us 2CO gas. Now here we have the heat is negative, so if it is negative, then we put it in the products, and of course we have to multiply the heat by 2. So minus 110 multiplied by 2 is minus 220, but we're gonna put it in the products. It's no longer negative, but it is positive 220 kilojoules. So if we are gonna write it, we're gonna write C solid but we don't forget the 2 like I did now. So 2C solid plus, you don't put 1 because they didn't tell you to write the number 1. They said if the coefficient is 1, don't write 1. So plus O2 gas, okay? It gives us 2CO2 gas plus the heat, which was 220, and don't forget the kilojoules. Now, question number 16. Write the reverse reaction of the above reaction without including the energy value. So they do not need the energy value, we forget about it for now. They need the reverse reaction, so we multiply it by negative, okay? And so then it's gonna be SO2 gas gives us S solid plus O2 gas. They said don't forget to include the state symbols. So SO2 gas gives us S solid plus O2 gas. Now they're telling us determine delta H for the reverse reaction. Of course, if we multiplied this by negative 1, so it could flip, then this heat value will be also, you multiplied by negative 1. So minus 297, okay, times minus 1, it will then be 297. But they told us don't forget to include the plus or minus, so plus 297 kilojoules. Question number 17. To change the temperature of a particular calorimeter and the water it contains by 1 degrees. Okay, this one is again, they need us to find delta H, and they didn't give us any specific value. So which equations do we use? Q over N if it is endo, and minus Q over N if it is exo. So how do we know if it's exo? We have combustion and temperature rise. So as we did before, minus Q over N, it is what? Minus C times delta T over mass, over molar mass, okay? And now we only substitute. We have minus 5 times 7 over 3.5 over the molar mass of C2H2 is 12 times 2 plus 4, okay? So then, if we put it on the calculator, it is gonna be minus 5 times 7 over 3.5 divided by 12 times 2 plus 4, and we are gonna get negative 280 kilojoules per mole. Question number 18, the final question. Calculate the heat change when 3.2 grams of methane is burned. This is the stoichiometry. Okay, so how do we do it? If we have methane, which is CH4, 1 mole gives us how much? Minus 819 kilojoules. How much then will 3.2 grams give us? Okay, what we need to do is that we need to find the number of moles first of all. So how do we find the number of moles? Mass over molar mass. So we do 3.2 over the molar mass of CH4, which is 12 plus 4. So the number of moles is 0.2. Okay, so if 1 gives us negative 819, how much will 0.2 give us? We do cross multiplication, so 0.2 times negative 819 over 1, we will get minus 163.8, but they needed to 3 significant figures, so we round it, it becomes negative 164. So the answer is minus 164. So let us check. Thank you guys for watching, and I hope you understood, and have a wonderful day.